Okay, freefall. This is a very, very common problem they have in exams. So let's imagine we've got a guy or a woman standing in a plane there. Let's have a look at the forces acting on them as he stands in the doorway. So the weight pulls the person down and the floor pushes back up, and that's the reaction. Now those two forces are balanced. They're opposite. They're going in different directions, and they're equal in size. So there's no resultant force. Therefore, the person is not accelerating, in this case, not moving, and it stays stationary, stays at the same speed, which in this case is 0. Okay, right. As he jumps out of the aeroplane, obviously a little bit of air resistance starts to hit against him, but his weight is still much bigger than the air resistance. So there is a big resultant downwards, and therefore the person will accelerate in the direction of the resultant, the words downwards. Now, as the person gains speed and goes faster and faster, he catches more air, and therefore the air resistance increases. And at the moment, therefore, you can see the air resistance upwards has got bigger, but it's still not as big as the force downwards, the weight there. So your resultant in this case, you take one away from the other, and your resultant is much smaller. The blue arrow there is much smaller than before. So there's still acceleration in the direction of the resultant, but of course the acceleration would be less because the resultant force is less. And eventually there comes a point where the air resistance acting against the person is equal to the weight downwards, obviously in an opposite direction. At this point, those two forces balance each other, they cancel each other out, so there is 0 resultant, and there is a constant velocity. And at this point we call it terminal velocity. Now this is, most students when you see something like this, they say, oh, the person's not moving. No, they're moving with constant velocity. If the forces are balanced, they move with constant velocity. That velocity could of course be 0, like it was in the doorway where the forces were balanced, but in this case they stay at the constant velocity they were going at a minute ago, which is about 180 miles an hour. And then of course what happens is the person opens the parachute. Now this time, because he's traveling at 180 miles an hour, and the parachute opens up, you get a massive force lifting it upwards. You can see the pink arrow there is enormous. The weight force, if you notice, has stayed the same throughout because your weight doesn't change as you fall down. So you take the weight away from the air resistance and you're left with a resultant in the opposite direction. That causes the person to accelerate in that direction, or in fact it is a deceleration. They begin to slow down. Now, whenever you see videos from YouTube on people jumping up there, people always think, oh, they move up. No, they don't move up. What's actually happening is the person filming them carries on moving down at the same speed, but the person who's opened the parachute is beginning to slow down. And of course, eventually there comes a point when the parachute slowed down sufficiently that the amount of air it catches gives just as big a force upwards as the weight downwards. And again, those forces are balanced, they're opposite and equal. There is no resultant force because the two forces have cancelled each other out, so they stay at constant velocity, perhaps it's like 8 miles an hour, so it lands safely. So that's what it would look like in one diagram. The weight, if you notice the red arrow, it stays constant, it always stays the same value, and the green arrow changes. I am missing an arrow from the one when he opens the parachute to start with. That would be an enormous arrow upwards, of course. And then at the bottom you can see the constant velocity. They've got the same speed. It travels at, say, 8 miles an hour because the air resistance and the weight are equal and opposite, and the forces are balanced, and there is no resultant. And that is a free fall, a very, very common exam question. You need to be talking about resultant forces, equal and opposite forces, balanced forces. You talk about weight staying the same, and you say that when the forces are balanced or when they're opposite and equal, there's no resultant, you must say it moves with constant velocity. And also you must talk about accelerations as well. So you must know when to use acceleration, when to talk about constant velocity, and talking about balanced forces.